Hi everyone, thank you so much for watching my video where today we're going to be solving absolute value equations. We're going to make sure we understand what the absolute value of something actually means first, and then we're going to evaluate some absolute value expressions that will lead us right into solving equations. We're also going to be looking at a number line where the solutions are already set on the number line and be able to write the equations off of that. So we have a lot going on in this video, so play along with me. If you want to grab a pencil and paper or a dry erase board and whiteboard marker and do the problems, or feel free to pause, play, whatever you need to do in order to understand the lesson perfectly. All right, let's go. So first of all, absolute value is the distance between 0 and that number on a number line. So you would need to imagine, and I can draw a number line for us, that if I'm dealing with a number line like this, and I have 0 in the center of my number line, just think of like a classic number line, and I have 1, 2, 3, 4, and then -1, -2, -3, -4, that the absolute value means what's the distance from any number on this number line to 0. And now distance is always positive. So if I was saying from me to the wall that's here, I would say it's 5 feet. If I was saying my distance from me to the wall on this side, I would also say 5 feet. I would never say negative feet because you can't have a negative distance. You can only have a positive distance. So if absolute value is about distance, then all of our results will always be positive, except for one special case when there's a negative on the outside of the absolute value. And we're going to be taking a look at that very soon. So here, if I said to you, what's the absolute value of 4? Well, really what that's saying is, look at 4, and how many units away from 4 is 4 away from 0 on a number line? It's 1, 2, 3, 4. So the absolute value of 4 is 4. Now for the second one, if I look at the absolute value of -4, and I do the same idea, I look at -4, and I want to figure out how far away is it from 0 on a number line. It's 1, 2, 3, 4. It's also 4 units away. So the absolute value of -4 is 4. Notice again, they're both positive. So the absolute value of a positive number is positive. The absolute value of a negative number is positive. Now, there's one special case where there could be a negative hanging out on the outside of the absolute value bar. Here's what ends up happening. I end up simplifying what's in my absolute value bars first. So imagine this negative on the outside doesn't exist. It's really because it's like -1 multiplied by the absolute value of -4. What's the absolute value of -4? We know it's 4. So then if there's a negative on the outside, then the result becomes -4. So here's what actually just happened. We took the absolute value of -4 first, which is 4. And then this negative on the outside got multiplied over because it's really saying -1 times that result. Okay, this is the only time your result is going to be negative with absolute values. Okay, let's take a look at evaluating some expressions, and then we're going to be solving some equations. So evaluating an expression would mean that I would look at this absolute value expression 2 times the absolute value of 3 minus x, and then plus the absolute value of x if x equals -2. So here are my steps. Substitute the value for the variable. So everywhere I see my x, I'm going to substitute in this -2. So 2 times the absolute value of 3 minus -2, notice I put it in parentheses, plus the absolute value of -2. Step 2, simplify the absolute values. So I've got an absolute value bar here and an absolute value bar set here. So I need to simplify what's in that first. So first of all, 3 minus a -2, 3 minus a -2 really means 3 plus 2. So this is saying 2 times the absolute value of 3 plus 2, plus, now this is just by itself. We can simplify that right now. What's the absolute value of -2? It's +2. Let's continue to simplify. So this is really 2 times the absolute value of 5 plus 2. And then the absolute value of 5 is 5. So this is really saying 2 times 5 plus 2. 2 times 5 is 10, plus 2 is 12. Awesome. Let's take a look at a couple more practice problems of this skill. Okay, here it says evaluate each expression if x equals -1, y equals 2, and z equals -3. If you feel like you can do these problems, I would strongly suggest that you pause right now, you copy these down, you try to work them out, and press play so you can see how you did. Otherwise, just follow along. Okay, this would become 10 minus 5 times my z is -3 plus 3, close the absolute value bars. 10 minus, I have to start using my order of operations to simplify. So this is the absolute value. 5 times -3 is -15 plus 3. Still have to simplify what's in my absolute value. So 10 minus -15 plus 3 is -12. Notice I keep bringing my absolute value bars down. I did not drop them off at all. You only get rid of the bars once you actually evaluate it. So the absolute value of -12 is 12. I wouldn't write the absolute value of 12. I would just write 12. So this is 10 minus, this result is 12, and 10 minus 12 is -2. Let's try the next one. Absolute value of -1 minus, my y value is 2, plus 6. -1 minus 2 is -3. So an absolute value of -3 plus 6. Absolute value of -3 is 3, plus 6 is 9. Good, let's try the next one. Absolute value of -2 times my y value of 2 plus my x value of -1. Close the absolute value bars, plus a -3. -2 times 2 is the absolute value of -4. Now plus a -1 really means -1. And then plus a -3 really just means -3. -4 minus 1. So that's the absolute value of -5 minus 3. And now once you actually evaluate the absolute value of -5, which is 5, that's when the bars are gone, and 5 minus 3 is 2. Last one of this skill. 3 times the absolute value of z, which is -3, minus x. So minus, now my x value is -1, so minus that -1, close the absolute value bars, plus absolute value of 2 minus my y value of 2. Okay, so this is now 3 times the absolute value of -3 minus a -1 really means +1 plus, and now let's clean this up. 2 minus 2 is 0. What do you think the absolute value of 0 is? 0. Okay. 3 times -3 plus 1 is -2. Notice how I just keep simplifying in my absolute value bars, right? Until there's just one little number inside those bars. And then we're able to go forward. Plus, the absolute value of 0 is just 0. 3 times the absolute value of -2 really means 3 times 2 plus 0. 3 times 2 is 6, plus 0 is 6. Awesome. Second idea here in this video is how to solve an absolute value equation. So we have to be able to understand how to work with absolute values before we can ever do an equation. So everything we just went through is really, really important now to be able to go forward. Solving an absolute value equation is going to be really interesting because this is going to be the first time when you're solving equations where you're actually going to get more than one answer. You're going to get 2 solutions. So far, every equation you've solved up until this point, there's only been one answer. It's x equals 4, or x equals -7.5. But now we're going to see that we actually can get more than one answer. And after we get more than one answer, we're going to plug them back in to check it, and I'm going to show you that they give us true statements. Okay, here's the 3-step process for solving an absolute value equation. Step 1 is to isolate the absolute value expression. So here I have this equation, absolute value of x minus 5 minus 3 equals 7. Step 1 is saying to get the absolute value expression, this part here, isolated. Isolated means to get it by itself. So in order to get this by itself, completely by itself, I have to get rid of this -3. This -3 is on the same side of my equation. It's kind of like in the way. So that's our first step, is to get the absolute value expression to be by itself. So we're going to add 3 on both sides, and now this is our result. Absolute value of x minus 5 equals 10. Okay, good. So step 1, done. Step 2, create 2 equations, one set for the positive value and one for the negative value. So here's the deal. I want you to imagine for a moment that this x minus 5 doesn't exist. I'm going to actually cover it up, and I'm going to fill it in, and we're going to pretend like we don't even know what's there. Got it? The absolute value of what is 10? 10, right? The absolute value of 10 is 10. What else is the absolute value of also 10? Absolute value of negative 10 is also 10. Do you agree? That gives you a true statement. So this is interesting. What I want to really figure out here is I want to figure out how can I get x minus 5 to be equal to a 10? Okay, what number would I plug in for x? So this x minus 5 becomes a 10. But then what number would I also need to plug in for x here so I get a negative 10? That way when I take the absolute value of negative 10, I'm still left with 10. So look what our 2 equations actually become. X minus 5 equals 10. X minus 5 equals negative 10. Interesting. This x minus 5 here just stayed exactly the same. And actually look at the first equation. All that happened from this equation to this equation is we got rid of the absolute value bars. The second equation, we kept the x minus 5, but the 10 becomes negative. So what we want it to set equal to stays positive and then becomes negative. And those are our 2 equations. Now these are just simple equations to solve. Add 5 on both sides, boom. Add 5 on both sides, boom. We actually get 2 solutions, 15 and negative 5. If I was to then graph, step 3, solve both equations and graph the solutions. Graphing the solutions just simply means to plot those points on an appropriate number line. So it can be any number line in the world as long as you have an appropriate one with proper scales and intervals, however you want it to be, and just simply plotting those points. Now think about it. If I went back and I plugged these values in, if I substitute in a 15, okay, that was my first answer, was 15. If I plug in a 15 here, what's 15 minus 5? 10. What's the absolute value of 10? 10 minus 3? 7. Good. My second solution was negative 5. So what would happen if I plugged in a negative 5 here? Negative 5 minus 5 is negative 10. What's the absolute value of negative 10? 10 minus 3, 7. So you get true statements for both. Okay, we're going to take a look at these absolute value equations here at the bottom, and we're going to solve them. All right, so first step, get the absolute value expression isolated. And here, I think we see it. It's already isolated, so that's good. So the first equation is 3 minus 2x equals 7. You just simply drop the absolute value bars, they're gone. Everything else just stays the way it is. The second equation would be to figure out how to get 3 minus 2x equal to a negative 7. Okay, so it's setting the first equation equal to its positive 7, and then setting the second equation equal to negative 7. Notice the 3 minus 2x never changed. It doesn't become 3 plus 2x. You don't change that expression. You're just changing what you're setting it equal to. You would go ahead and solve these 2 equations, okay? That's just really basic work at this point. And then once I solve those 2 equations and I get my 2 solutions of negative 2 and positive 5, I would graph them on any kind of appropriate number line. Next one. I have to get the absolute value expression isolated, and clearly this one is definitely not isolated. It's being multiplied by 2, and there's a minus 5. Now I want you to imagine for a moment that this equation really looked like 2x minus 5 equals 21. What would you do first step to start to get x by itself? Okay, to solve for x in this equation. Wouldn't you add 5? And then after you added 5, you would divide both sides by 2, right? So you would add 5, you'd get 26. Then you divide both sides by 2 and get 13. So look at this. If I say to you, this absolute value expression needs to get isolated, this is basically in the exact same spot that x is. So we follow the exact same steps we would have done here. So the first way to get this 2g minus 3, the absolute value of that, isolated is to add 5. So we get 2 times 2, the absolute value of 2g minus 3 equals 26. Then what would be the next step to get this expression by itself would be to divide both sides by 2. Okay, So we got rid of our 5s, and then we got rid of our 2s. And now we're able to set up our two equations. We have to set 2g minus 3 equal to 13 and 2g minus 3 equal to a negative 13. Okay, let's go ahead and add 3 on both sides. Our first solution ends up being 8, okay, because you get 2g equals 16, so g equals 8. Add 3 here, we end up getting negative 5. And if I plot my two solutions, just negative 5 and 8 somewhere on our number line, an appropriate number line. Last one, okay. Something I haven't mentioned yet is that when you're dealing with absolute value equations, you have to make sure it makes sense. You have to make sure, could you take the absolute value of something and get 13? Sure. Could you take the absolute value of some number and get 7? Sure. Because the absolute value of anything is always positive. Say it with me. The absolute value of anything is always positive. The absolute value of something is always positive. So if you have an absolute value expression by itself and it's set equal to a negative, is that even possible? Could you even take the absolute value of any number and make it negative 5? Like, what if this became negative 5? What's the absolute value of negative 5? 5. It's never going to be negative. There's no negative on the outside. This expression is completely by itself. So this is actually no solution. There's no possible point you could ever pick in the world. And if you can find one, you can comment in the comment section below. I'll give you $100. You're not going to be able to find a number. It just won't work. Because the moment you plug in a number for p and you add 6, and then you take the absolute value of that answer, it's always going to be positive. That's it. Awesome, guys. Last part of this lesson is learning how to write an equation when you have the points already plotted on a number line. So this is kind of the opposite function of it now. It's looking at this number line and being like, oh, negative 4 and positive 6 are the solutions. What was the absolute value equation that went along with this number line? So I'm going to show you exactly how to do that. Now, the first step, there's 3 steps. Usually there's a lot of 3 steps for everything that I'm teaching. Step 1 is to calculate the midpoint. Midpoint would be the number that's directly in the middle of those two solutions. So the way you calculate the midpoint, you can either visually see it. Remember you used to have to find the median in a list of numbers and you would work your way into the middle and figure out what was in the middle? That's the midpoint on a number line. It's the same idea. Or you can use a really easy formula. It's really just taking the average of those two numbers. It's taking x sub 1 plus x sub 2 and dividing it by 2. So taking negative 4 and 6, adding them up and dividing by 2. Negative 4 plus 6 is 2. 2 divided by 2 is 1. So the midpoint, the number in between those two solutions, is this dash at 1. That's my midpoint. So that's step 1. We have to figure out what's in the middle of those two solutions. And that's our first important number. Step 2, find the distance from the midpoint to either endpoint. Now, this is saying go from the midpoint to either endpoint. Look, 1 to 6. What's the distance from 1 to 6 on a number line? What's the difference in between them? The distance going from 1 to 6. It would be a distance of 5. What if I went to the other endpoint? What's the distance from 1 over to negative 4? The distance from negative 4 to 1 is also 5. It should be identical. If you're in the middle, then it's going to be equal lengths on both sides. So that's the second number that we need. We need the distance, and the distance between those two numbers is 5. The last step is to use this formula. So the formula, just going to move my screen, the formula for the absolute value equation is the absolute value of x minus the midpoint equals the distance. So we know the midpoint, it's 1. We calculated the distance, it's 5. So look how easy the equation is. Absolute value of x minus 1 equals 5. It's x minus the midpoint set equal to the distance. Now look at this equation, x minus 1 equals 5. If I went back up here, negative 4 was one of my solutions. What's negative 4 minus 1? Negative 5. What's the absolute value of negative 5? 5. If I plug in a 6, 6 was my other solution. 6 minus 1 is 5. The absolute value of 5 is 5. Works perfectly. So I have 2 examples for you here. If you feel like you want to try them, go ahead and pause. Otherwise, stay with me. So first step, I want to figure out the midpoint between -7 and 13. So I add them and divide by 2. I'm taking the average of those 2 numbers, which is 3. So 3 would be my midpoint. I then need to calculate the distance from the midpoint to an endpoint. So this distance here, how do you go from a 3 to a 13? It's 10. So my midpoint is 3. My distance is 10. My formula is this: absolute value of x minus the midpoint equals d. So absolute value of x minus 3 equals 10. That's it. Next one, midpoint between -16 and -10. Let's add them up, divide by 2. So -16 plus a -10 is -26. Divided by 2 is -13. So the midpoint in between them is a -13. And then I need to find the distance from -13 to 10. Or I can always go back from -13 to -16. The distance between -13 and 10 is 3. Distance is always positive too, right? It should be positive. And notice if it's going to be equal to the distance in the formula, it's got to be a positive number. And then last is my formula. So it's absolute value of x minus the midpoint. So x minus a -13 equals my distance. And we know better than this. What's x minus a -13? X plus 13. So it's the absolute value of x plus 13 equals 3. I hope this video was helpful for you. Thank you so much for watching.